Okay, let's look at lesson 25, pages 255 and 256. If you've taken a few minutes to go ahead and take a look at the example, notice that they are asking for the distance between R and S. Now, on a coordinate plane, when we have to look for the distance between R and S, it is challenging because it is a diagonal line. If it's a straight line following one of the grid lines, we can just count the spaces, right? We can count the jumps. We can also do that going horizontally along the x-axis. But when we count diagonally, there is no square unit that we can count. So we have to use Pythagorean theorem to do this. Now, what's cool about Pythagorean theorem and coordinate planes is that we know that this is automatically a right angle because these two lines are perpendicular. That's just the way graph papers are made. So what they do in this problem is the Pythagorean theorem that we just used in our last little section. This area I thought might be kind of confusing to you. In order to find distance, there is a formula that we can use. To find distance, it is P minus Q. That's actually what mathematicians use. P is going to be one of your coordinates, and Q is going to be the other x coordinate. So notice that I have it in absolute value signs. So what they did for A, just to help you understand, in A, they did 5 take away 1. So where did they get that 5? So in order to find A, that means we're looking for this distance here. They are looking at the 5, the y. So now remember, this is x, this is y, and this is x, and this is y. In order to find the distance of A, and notice that A is our y, it's vertical, so we're using our y coordinates. Now, they started with 5, and they subtracted the y coordinate from t, which is 1. So we got the absolute value of 5 minus 1, which is 4. That's how they got this number. Now, B, notice that B is running along the x-axis. It is the horizontal. So we are going to look at the x values in our coordinates. So notice that this is x and this is y, and this is x and this is y. So to find the distance of P minus Q, they took the negative 5, which is our x value, and plugged it in. Then they're subtracting our other x value, which is a positive 3. Now, a negative 5 take away a negative 5 take away 3 is a negative 8, but it is absolute value, so we are actually going to use the number 8, and that's how they found that number. So just in case that was a little tricky, that helps you figure out what they meant here. Now, another simple way to do this is just to count our boxes, right? We've got 1, 2, 3, 4, 5, 6, 7, 8. Notice that I just had to move 8 spaces. If I wanted to count my vertical, I would just count 1, 2, 3, 4. That is another way to do it. So they showed you the challenging way. You also can just count. Okay, so using that information, let's go ahead and look at number 1. Describe a method other than the one used in the example that you could use to find A. I think I just told you that. So go ahead and use that information. Remember, we did some counting here. Number 2, explain how you know that triangle RST is a right triangle. I think I explained that already as well. Remember that a coordinate plane, our grid lines are perpendicular to each other, and a perpendicular line means that we do have a right angle. It is 90 degrees. So go ahead and explain that in your own words. Okay, number 3, suppose point S in the example was set at 4, 1. Okay, I have to think about that a minute. Suppose point S in the example was at 4, 1. Okay, let's take a look. If S, right now it's at 3, 1. They said, what if it's here? So in other words, what happens to the length of our triangle? What happens to it? It gets longer. So if our length of our leg gets longer, what's going to happen to our hypotenuse? Is that going to get longer as well? Okay, let's talk. Let's keep reading. Would the distance between points R and S be greater than or less than 8.9? So remember, they found the distance of this hypotenuse, the length of the hypotenuse was 8.9 when it ended at 3,1. Now that it ends at 4,1, is this larger or greater than 8.9? Hopefully you figured out that it would be greater, because now our B is actually 9. So we would have 4 squared plus 9 squared, which would be what, 16, or would equal C squared, which remember C squared really is RS, and 81 equals C squared. So we end up with 97 equals C squared. So the square root of 97 is going to be greater than the square root of, remember they were looking for the square root of 80. Okay, let's go ahead and look at the back. How far is point E, 5,3, from the origin? Okay, so here's the origin. Remember, origin is where the X and the Y cross. And here is 5,3. They want to know, what is this distance? Now remember, when we are looking at diagonals on coordinate planes, we can't count spaces. So that means we need to turn this into a right triangle. There's 2 ways to do this. How could you turn this into a right triangle? Go ahead and do it on your own first. Now, you should have either drawn a rectangle here, or sorry, not a rectangle, a triangle here, or you could have drawn it going this direction. It doesn't matter as long as you have a right angle. Now, how could you figure that distance? If you need to, go ahead and pause, see if you can solve it on your own first, and then I'm going to continue working. Okay, notice that I notice 1, 2, 3. This is 3. 1, 2, whoop, 1, 2, 3, 4, 5. Did I count that right? 1, 2, 3, 4, 5. Darn, I was hoping it was going to be a Pythagorean triple. It's not. Okay, A, B, and then remember, this is my C. This is my hypotenuse. So I'm going to go ahead and go A squared plus B squared equals C squared. I know that A is 3, B is 5, equals C squared. I don't know C. That's what I'm looking for. So 9 plus 25 equals C squared. 9 plus 25 is 34. Okay, is C squared. Now, hopefully you have your calculator. I notice that this is not a perfect square, so you are going to have to type this in. I find the square root of both 34 and C squared. Those cancel. And I already looked it up. The square root of 34 is about 5.8. Did you get the right answer? If not, go back and look and see how yours is different than mine. Okay, let's look at number 5. Connie says that she can use the equation 6 squared plus 5 squared equals C squared to find the distance between the X and Y in the diagram to the right. Do you agree with Connie? Okay, so she wants to find the distance between X and Y. Oops, got to draw my line straight here. Okay. I'm going to draw my triangle. Doesn't matter if you go above or below, as long as you have your right angle. I notice that this is 1, 2, 3, 4, 5. And I notice this is 1, 2, 3, 4, 5, 6. And this is A, this is B, over here is C. Yes, you can. Go ahead and explain why. In your own words, you can use how you've drawn the triangle and use the right angle. What is the distance? So if you've done this correctly, remember you're going to plug in A squared, oops, plus B squared equals C squared will become 5 squared plus 6 squared equals C squared. You should have 25 plus 36. And that would become 25 plus 36 will become 61 equals C squared. And if I find the square roots of both, C is about 7.8. Okay, how about our last one? Which point in the diagram at the right has a distance of the square root of 130 from point R? Explain how you found your answer. Okay, well, I'm going to look at what would be the square root of 130. So I use this. I always keep a chart close. It's going to be somewhere between 130 somewhere between 11 and 12. So which one of these has a distance of somewhere around 11 or 12? What I would do is I would just start testing. I'm thinking S might be that one because I'm thinking that's going to be not far enough, and that one's not far enough. So I'm thinking, let's go ahead and test it. Okay. Go ahead and plug in what you know. Go ahead and pause the video. I'm just going to go ahead and put in an answer real quick so you know what it is when you get to it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, if you did this correctly, you should have found out that S is the one that's about a square root of 130 from R. And notice that I drew my triangle, I plugged in my side lengths, I calculated Pythagorean theorem, and I got to 11. Okay, I hope this helps. We can chat later.